Get it. Hello, Alberto.
No.
So if you are curious what is Adriano's otter, this is a kind of secretary provided by Zoom. It will take care of the what we say, the action items and things like that, and at the end it will give me the notes. Hi, Steve.
Hi, good evening. Buonasera.
Buonasera. Tutto bene? Ciao, Jim.
Aloha nui loa.
Aloha. Ok. Molto bene. Oh, okay. It's 9 o'clock right now. We will wait some more minutes for maybe other friends to join. And yeah, we're going
I'm
ahead.
sorry I haven't been with you guys for quite some time now. My apologies.
For what?
No, for not not having been with you for a while at other meetings.
Yeah, but never mind. No need for apologizing. Yeah,
Thank you.
all of us are volunteer, you know. So we are
Indeed.
doing what we can when we have time, etc.
Love is never having to say you're sorry.
Yes, I'm sorry. That's true.
Very good, Irving.
Hi, Ghanim. By the way, yeah, just today I got let me say an intimidating message trying to dissuadere to Alberto, help me. What is the English word for dissuadere? Dissuadere.
Dissuade.
Dissuade. Oh, so it is an English word.
Dissuade.
Okay. To dissuade me from bringing ahead the 18 SDG initiative. And so I don't want to say who,
Hey,
but it's okay, it's an important person. Just let me say that. So, but however, I'm not scared about that, and I think we will have to go ahead. Yeah, and even with more determination than before, because if they try to fight, it means that they are scared by this initiative. So
Okay.
we have to go ahead. However,
What may be the reason why they want to fight against us? What may be the reason? I do not
they
understand.
no, they don't give any reason. Just they say they say if you want to stop your troubles and you're having troubles, if you want to stop, the solution is simple. Just stop pursuing this. Stop working for the 15th of September session. If you want to go ahead, you will have to behave in another way, and there will be challenges, of course, but something like that. A very confused message, and without any justification, just a tentative to, you know.
sorry, Adriano, my signal's a bit bad here, so I missed exactly who these were. Who is it that's trying to dissuade you from this?
No, I don't want to say who, because
Oh, all right.
yeah, okay.
All right.
But just to let you know that our initiative is noticed, is not yeah, because we have now 44 organizations with us, you know, and some of the very big biggest ones, the National Space Society and the Mars Society and other, and Frank White. Frank White is the author of the overview effect. It's a very important, well recognized everywhere guy. So yeah, I think we are disturbing someone. However, yeah,
Maybe someone is disturbed.
yes, that's true. And this was expected, however. And but of course I will need support, you know, because of course the one that is bringing ahead everything is me, and therefore I think it will not be the only message of this kind that I will receive in the next weeks and months.
Coraggio.
Coraggio, esatto. Yeah, but I have also some very good news, and it is the Mexican Space Agency that joined our coalition. So we have an important space agency now supporting the 18 SDG, and we wrote to the Mexican permanent representative at UN if they can give us a physical room for the 15th of September, and also if they want to officially present the 18 SDG proposal to the UN, because you know that we need a state party to present it. It's not enough to be observer at COPUOS. NSS is observer at COPUOS, and Carlton Johnson made a speech the 5th of June presenting the proposal of our proposal of the 18 SDG. But that's not enough. In order to be really proposed to the UN, we need at least one state party, one nation, one country to endorse it and present it officially. So we asked to the Mexican government to do that. We also asked to the government of Chile to do that, and several other governments. But we think that maybe with the Mexican government we have a chance to succeed. So let's hope and let's go ahead. Well, now is 7 minutes past 9, so I think we can begin our meeting today. Of course, the chairs are Werner and Jerry for this committee. This is the Transport, Mining, Industry, and Near Earth Orbital Debris and Near Earth Objects Committee of Space Renaissance Academy. The chairs of these committees are Werner Grandl and Jerry Stone. So I will give the floor. I know that Werner prepared a presentation about his idea of a factory in L1, right? L1? Or,
Yes.
yeah. Okay. So I think it will be a very interesting presentation. Then we can discuss about that. And also, I would like to recall that just yesterday evening, we had a beautiful webinar with Al Anzaldua on orbital debris, and it is on YouTube. Of course, it can be seen, and I think Al brought to light several important concepts about the legal problems and the possibility to start a business. That is the real important way to start solving the orbital debris issue. Okay, So this was my premise. Werner, the floor is yours. Jerry, if you have anything to say, to add, maybe make your part in moderating the meeting and the chairing and so on. Please, the two of you.
Well, I will try to free my screen. So just a moment. I hope that this will. I hope you can see it.
No,
No, we are not seeing.
You
Yes.
are not seeing this.
You didn't share so far.
Wait a moment.
Yeah, however, Jerry wrote that he is currently in a dialysis process, therefore he should remain muted in order not to disturb the other patients that are with him in the room. Okay, we are seeing your desktop now.
Are you now seeing it?
And yeah, and the presentation,
Well,
yes.
well, yes, well. Okay, so I will start.
If you can go full screen, it would be better.
No, this isn't possible. I'm sorry for that, but I hope you can read it. So I
Yes.
will start, I think. So I have made some thought about a preliminary concept for an industrial plant on the Lagrange Point L1.
Okay.
What may be the tasks of such an L1 industrial plant? Of course, a processing of lunar and asteroid material from near-Earth asteroids, then collecting and processing orbital debris. We have learned yesterday from Alfred that there are about 8,000 metric tons of orbital debris. So we can, it seems to be not so much, but it could also be added to the space industry between Moon and Earth. Then the next point is extracting iron, aluminium, titanium, and other metals from lunar and asteroid ore. Then the production of building material such as steel bars, aluminium panels, tubes, and so on. And last but not least, I think the transport of semi-finished products to the construction sites on L4 and on L5 for our new, maybe our base habitats of the O'Neill type, I would say. Now, first of all, we can look at the possibilities of the asteroid mining, which is a very big challenge for our future in space. Now, you can see the most important geochemical groups for meteorites and asteroids, with all the typical elements occurring in the minerals there. You see that there are many elements such as iron, nickel, gold, of course, and of course, what is important also the so-called rare earth elements, which also are very, very important to our industry on Earth, especially, but also in the future for space industry. Now, how to use these resources for the benefit of mankind? The first step, of course, is to send robotic probes to near-Earth asteroids, preferable to the so-called potential hazardous asteroids. So, why have I chosen the Lagrange Point L1? because as you can see, the Lagrange point L1 is in the middle between Earth and the Earth orbit, of course, and the Lagrange points L5 and L4. So if you have an industrial facility, a space factory on the Lagrange point of 1, you can gain material with the help of a mass driver, of a lunar mass driver, which is relatively near to the Lagrange point L1. And if there is a factory, then we can transport the products to low Earth orbit, as well as to the Lagrange points L4 and L5. And on the other hand, we may transport orbital debris, about these 8,000 tons. We heard yesterday from Alfred, can also be transported easily to the Lagrange point L1, which is in the center of this entire system. Of course, what I said before, electromagnetic mass drivers on the moon accelerate cargo containers to reach the Lagrange point L1. I think this was in the first time proposed by Gerald O'Neill in the 1970s. In L1, industrial facilities produce building material for space colonies in L4 and L5. This is the goal, this is the main goal. Industrial products made in L1 can be used also for structures in low Earth orbit, for example, for solar power satellites. So this is the system which we may propose there. Now, what are the most important minerals on the moon for heavy industry in space? We need, of course, heavy industry, aluminium, iron, titanium, chromium, and so on and so on. These are just the most important minerals. And of course, we must extract aluminium, and of course several other metals like iron and titanium from these minerals. For example, there is a so-called hydrogen reduction from the mineral called ilmenite, and this is the process. So in this chemical process, with a high process temperature of 900 degrees Celsius, you get iron, you can get water, and with the electrolysis, you can get, of course, oxygen. Yeah? Of course, you have to, or you need a certain amount of hydrogen to start this process, which can come from Earth maybe, and then it is a closed process. You can, of course, within this electrolysis, you can, of course, recycle the hydrogen and use it again. And you can gain, of course, for example, iron, water, and oxygen, which is very important for lunar industry and for space industry in the Lagrange points L4, L5, and also in low Earth orbit. Now, a second consideration of mine, which I think would be important, it is a hierarchy in the L1 industrial plant. In my opinion, on top of the hierarchy, there should be a human crew. There should always be humans in the hierarchy on top. And this human crew gives order to artificial intelligence and controls the robots and the manufacturing. And the next level of this hierarchy is artificial intelligence and robots. And these artificial intelligence and the robots make the industrial processing and manufacturing in zero gravity or microgravity in L1. But it's always, everything is led by the human crew on top. So as a result of these industrial processes, there we come to the transport of material to L4, low Earth orbit, and L5. On L4 and on L5 we have our space habitats, and of course to Earth orbit. Now I found a very interesting NASA concept of a space factory. It dates from 1970. I think it is a famous picture. You can see on the one hand, you can see solar panels and on the one hand robots, and on the other hand humans with semi-robotic devices, and here a space station or a space factory which can be built. I think this is in Earth orbit built, but I think it would be a location in the Lagrange Point L1 would be the better one, the better site for this. So those are my very short considerations about this item, and I would like to discuss with you some pros and cons of my ideas. Thank you.
Thank you very much, Werner. I think it's very, very interesting presentation indeed. And yeah, maybe you can stop sharing.
Yeah.
You have a red button in the bottom.
Okay, something.
Yeah.
Okay. Again, I'm with you.
Great. So, okay. Who wants to comment? Say something about this presentation?
If I may, please, Adriano.
Sure, go ahead.
I remember reading with fascination this book, Colonies in Space, which I think you're probably all familiar with, which was exactly along these lines, Werner, of course. And at the L1 position, would that be the material sent up by the mass driver from the lunar surface? Would that be directly captured by the facility at L1 for processing, or would there be a mass catcher, as was, proposed in this book, like a giant ice cream cone, and then transported to the processing facility?
Yes, I think one can imagine some containers which come from the moon, and they may be caught by a net or something like this, and then brought to the facility, to the industrial facility. Right. I think it was also the idea that Gerald O'Neill had in the 1970s. But of course, yes, we can develop other methods.
Right. Yeah, it's about time I read this book again, actually. It's been a long time, but yeah, I found it fascinating, and the whole concept of the mass driver and things. So in fact, the material itself would be, oh, there it is. That's the mass catcher.
Yes, this is the catcher.
Yep. So on page 120, so the material itself would be, if I read it right, would be accelerated along the mass driver in these bogie trucks, and then at a certain speed, which I can't remember, it's in here, would be ejected from those trucks. And in fact, the raw material just comes up in a constant stream from the end of that mass driver. Yes.
Yes, yes, you have to make some constant streaming of material, and then you can catch the material near the Lagrange Point L1. But one can also think of a spaceship or of robotic spaceships, which can also catch these containers and bring them to the facility.
Right. Thank you. Of course, I was thinking also, because you mentioned that perhaps the hydrogen to begin this whole electrolysis process would be brought from Earth, but also, as has been discussed within recent times, of course, the existence of permafrost ice on the moon. So if, as has been proposed by ESA, at least, to mine that for separation of hydrogen and oxygen.
In this case, we would have an advantage, of course.
Yes. Thank you.
Anyone else?
I have a question. I'm sure it's addressed in the article on mass drivers, but how is the momentum dealt with by the mass catcher?
Of course, I don't know exactly now, but I could study the literature once more. I don't remember what Gerald O'Neill wrote about this, but I think he has very carefully calculated this point. Of course, they would have a high velocity, of course, maybe some kilometers per second or something like this. So it would not be so easy to catch them.
Could I make a comment on that if I'm working? I don't know if you can hear me, but
Yes.
Okay, thank you. The L1 point, thinking back to that graph that Werner just showed us, the L1 point is kind of like at the top of the hill from different directions. If you're shooting something from the mass driver from the moon, you're giving it just enough oomph to get to L1. L1 is the magic balance point between Earth and moon's gravity. So an object sent by mass driver from the moon, for example, could be done at such an acceleration that it basically loses almost all of its speed by the time it gets to L1. Same thing from stuff being sent up from low Earth orbit. It loses all of its speed by the time. So the capture from the moon and from low Earth orbit might not be that difficult.
Okay.
From those. Now, it might be a little trickier going L4, L5 back and forth between those two. But even there, you've got some orbits that are basically in the same direction at the same speed around the Earth. So I don't think capture is going to be that hard of a problem if we learn how to be very fine-tuned in our acceleration from the source.
Yes,
that's
the
all.
acceleration must be very fine-tuned, of course.
Very fine, but we're doing that.
Yeah.
So.
But I think maybe from the point of engineering, those containers are very small, and you have to find them, of course, if you catch them. even if they are not very fast when they reach L1, you have to find them because they are small. But I think this is a problem which can be solved, I think.
Thank you.
I have one question, then I have some comments. But my first question is this one: why did you only mention low Earth orbit and not medium, MEO or GEO orbit? I think industrial settlements could take place not only in low Earth orbit, but also at geostationary orbit and in the middle. What do you think?
It's also possible in the geostationary orbit, of course, but my idea was that there will be some products which would have been also possible to be transported to Earth surface.
Okay, so to be
human use.
Yeah,
Yeah.
as near as possible to Earth.
As near as possible
Yeah,
to
I understand. Yeah.
land on the surface of Earth, of our planet.
Yeah, okay. It's very fascinating for me. And I start, of course, considering my past, my professional history, that I was a project manager in the field of industrial automation and continuous process control and this kind of things. I am imagining that if we think about an industrial plant, a manned industrial plant, of course, not a fully automated one, we have to think basically to two kinds of automation. One is for the factory production, that will be made by robotic machines and supervised by artificial intelligence, of course, to manage and coordinate all the industrial activities. And the other system, big system needed is the control of the station, the continuous control of the environment inside and outside the plant. This is normally done on Earth by SCADA systems. SCADA is an acronym meaning system for control and automatic monitoring or something like that. And it is quite interesting to think about a SCADA system supervised by an artificial intelligence that will somehow make, in part, the job of the man, because all the SCADA system have, synoptic panels that represent all the plants, with all the actuators and sensors of the plant, and is able to raise alarms. And normally, a human operator is monitoring the monitoring system and react to possible alarms, to accepting the alarms and try to recover the alarm, of course, because usually an alarm has a cause, is not coming up just that way, And so there will be a lot of let me say analog variables to be monitored in this kind of settlements. Even the radiations coming from the sun and from the galactic sources should be monitored, and to raise alarms in advance before some storms are coming that will make very dangerous to I don't know, some EVA activities, for instance, or other things. So yeah, it would be very interesting to study the the monitoring and supervisory system of this kind of plant, and that it will be a little bit more complicated than let me say a city. A city just for no, it would be complicated enough. Also a city, because you have to think about some thousand people and their life supporting systems and all this kind of thing. But even in an industrial plant. So yeah, it would be quite interesting to develop this idea, you know, and maybe make a small project just to, not with the ambition to make a feasibility study, but just to put all the things together, you know, to say that these are the subsystems that will be needed, and this is what the requirements, that we can imagine. And it could be Ghanim, it could be another theme for a workshop like the one we are going to hold, international workshop based in Kuwait, but open to international, to worldwide participants. And that will be for an habitat. The topic will be an habitat in a Lagrange point. 400 people right now, because we don't want to engage people in a science fiction project, but something more near to feasibility, you know. So yeah, this could be another theme, interesting theme. Think about a factory, and thinking about a factory, we have to understand to produce what. The presentation say materials for construction, so maybe semi-worked items for construction on the moon, on L5 and L4 and so on. But we have to think that if we recover, we also recover orbital debris, Earth orbital debris. The factory will need to have some processing system to reprocess the metals, the plastic, the electronical components, because it's logic to think that many space debris we have fragments of electronics inside, because all satellites are made of aluminum, electronics, and plastic, more basically. So we will find all of these things in the fragments that we will find. And and even if we will recover big wreckages, we will need to dismantle them and to separate the metals from the plastic from the electronic. And after having done that, to reprocess everything to get parts that can be, I don't know, let's think about the upper stages, rockets upper stages that are orbiting, a lot of them in Earth orbit. They can maybe be used as they are somehow, because they are cylinders that can be refurbished to get modules for habitats or other kind of things. So this maybe to be brought to the moon to build habitats on the moon. So yeah, various. But however, what we have to think is in such kind of industrial plant to have a big workshop where there will be expert technicians, not only robots, saying, okay, what do we have here? Oh, this is a large fuel tank. What we can do with that, and then they will decide what to do, and to work on it. So yeah, very fascinating topic to be developed in the next months, maybe.
I have a quick question, if I may ask. Regarding the lunar regolith, it's supposed to be radioactively contaminated. There is no atmosphere, and it's bombarded with gamma rays, X-rays, highly energized particles. So, is there any consideration that we should take to deal with contaminated raw materials?
So you are talking about moon materials?
Yes.
The regolith, the moon regolith that you say it is contaminated, radioactive?
Yes.
Or it could be, or we know that it is.
I'm not sure actually. That's the question. If it's but I am assuming it's contaminated because it's exposed to gamma rays, X-rays all the time. So I think it makes sense that it is contaminated, and therefore, if this is the case, then we should take any consideration regarding radioactivity, contaminated materials.
I think, as far as I know, the lunar material, the regolith, is not very radioactive. There is some danger, of course, on the moon by rays from space, but the material itself, I think, is not very much contaminated. It is, of course, if you think of helium-3, of course, this is a very interesting substance for nuclear fusion and so on, but it is not very, very radioactive. I think the main danger for humans in space is from the rays from space. On the one hand, from solar flares, and on the other hand, from deep space radiation, but not from the material from the moon. I think, as far as I know,
I believe you are correct that the exposure to radiation, which of course is a factual thing, does not necessarily make the exposed material very radioactive.
Yeah, Steve.
Great. Just 2 points. One, that's a very interesting point you brought up, Ghanim. I don't know for myself what the results were from all the samples that were brought back to Earth from the Apollo missions, whether it was all of those samples were found to be radioactive, and if so, to what level? And secondly, all the more recent designs of colonies, both for the moon and Mars, that I've been able to see, would be, in order to protect the crews manning those stations, the actual habitats would either be subsurface, or in fact, if there were surface-built domes first, then they would be covered with regolith, either lunar regolith, Martian regolith, to protect the crews from solar and extrasolar radiation, but also, of course, from micrometeorites.
Yes, the interesting thing about regolith is that it is not very insulating material, because regolith is similar to glass, let me say, to be very superficial in a chemical analysis, However, from the point of view of insulation, is not that great. It is better if, and some experiments were made in Italy and in the Scuola di Pisa, Santa Rita di Pisa, mixing the regolith, of course, a simulant of the regolith that you can find on volcanoes, just to be quick. A simulant of regolith mixed with polymer. So you just squeeze polymer, a past, a toothpaste, something like that, in the regolith. Mix that, and it will grow, of course, expanding, and the regolith will give some kind of solidity, you know, to the brick that you will get.
Yeah.
And the polymer will add protection, because polymers are very much better protective materials with respect to glass similar materials. So we made some experiments, and then I brought these experiments to Thales Alenia Space in Torino, where they made a test about insulation for radiation, and they found it was quite good insulating material, this mixing of regolith and polymers. And of course, yeah, we also made some hypotheses to use inflatables to get bricks, let me say bricks of various shapes. So whoever using inflatable bags, let me say, squeezing inside this mixing of regolith and polymers, this will fill up the bag, and at the end we will have bricks of a regular shape that we can use to build any kind of construction. Yeah, this something I personally testified, let me say, because the originating idea was mine, and those researchers followed me to test it. Okay.
Yes, but I think the question is if you need water for this process of what you told us now. If you need water, so you need to have water on the moon. Of course, we have water on the moon.
You mean to get the polymer?
Yes.
Well, yes, I think some portion of water is also needed, but not very much.
No, I can say something, because I'm swimming polymers every day because it's my job. No water is needed to make polymers. No.
Okay. So I was wrong. Okay,
but you need hydrocarbons. You need the hydrocarbons, and those I don't think you can find on the moon.
Okay.
I suppose that polymers must be brought from Earth, because on the moon I don't think there are hydrocarbons.
Yeah, maybe in some asteroids. Why not?
Yes.
On the asteroids, yes, but not on the moon. No, starting from not only methane but ethylene, ethane. I don't think they can be found. Of course, they are very much present in space in many places, but not on the moon.
Yes, there are so-called C-type asteroids, which have also carbon and so on inside. And so we could mine those asteroids and we get carbon.
Yeah.
But first of all, we have to catch such an asteroid, or to reach such an asteroid near Earth.
Good. So I'm seeing many things are written in the chat, and the good thing is that at the end of this meeting, Zoom will save the chat and the full transcript of what we said. Therefore, we can have the materials to be used if we want to go ahead with our project and maybe develop something more from this first presentation and discussion. Okay. Anything more?
just to ask whether, I mean, in this discussion, of course, whether people already are familiar with this book, Colonies in Space. I
Of
know
course,
Jerry
yes.
is, obviously, but
But that is, sorry, why is it written Ray Bradbury?
no, the introduction was written
Ah,
by
the introduction.
Heppenheimer. T.A. Heppenheimer was the author. Sorry, for some, I need to check the controls on this camera because it's obviously showing things in reverse.
This is the same thing in Italian. Colonia.
Ah, okay. That's Gerard K. O'Neill's book, though.
Yes, yes, this is Gerard O'Neill book.
This is Heppenheimer. It's not the same book.
Okay, I didn't know about that. Yes,
Jerry
yes,
put in the chat
Jerry
that
wrote it. Jerry wrote it
in the chat that in
chat.
fact both books came out around about the same time.
Yeah, so I have to look for that. I think it's very interesting too.
That's my only real knowledge on this sort of subject. I haven't done any in-depth studies further from having just read this book, in fact. But I think, you know, a lot of I mean, you guys are more professional in this area than I am, but maybe some of the original concepts from that book and obviously Gerard K. O'Neill's books still hold true in terms of basic design for such colonies and smelting areas, etc.
I might offer up a science fiction reference for some inspiration, and that would be "The Moon is a Harsh Mistress."
Heinlein. Yes.
By Robert Heinlein.
Robert Heinlein. Of course.
I thought it was a good balance of scientific, pretty much plausible, except possibly the intelligence part, but thus you have science fiction, but the use of mass drivers and many of the other things may at least provide a diversion.
Yeah, and on the scientific side, we should not forget Kraft Erike. That by the way, I gave a lecture on his lunar development paper in 2022 at our festival in Berlin, and I can maybe share the link to the YouTube video. Let's see if I am lucky. I'm afraid not that lucky. But okay, but we have the what I have found, the original Kraft Erike lecture.
Capability of crew to sleep was varied with the individual because the conditions were very poor in the module. The metabolic rate and energy consumption was reduced on the lunar surface. Average walking speed on the moon
And
was
this is
respectable 2.3
this is Kraft Erike.
in those relatively clumsy spacesuits and the heavy gear that they had. Then it took a certain amount, 50 to 70% in the overall extremes, 20 to 100% longer to perform work, but the adaptation to perform faster was quick. Only the Apollo 15 crew took longer to return to normal and fell out of the general framework, and it's still not yet clear exactly why.
Oh my God!
Well done. When was this lecture, Adriano?
It was maybe a few months before Eric was dead.
Because you have only
In
one
1984.
1/6 of a G, and some people doubted that the 1/6.
And is it available on
1/6
YouTube?
I am sharing. I am putting the just a moment.
I can quickly take a look.
The link. Yeah. Yeah, it is more than 2 hours. The lecture. Quite interesting. Fantastic.
And you have the link for that lecture, yes?
Yes, I
You just put it up there. Well done.
in the chat. Yeah.
Thank you very much.
Yeah.
Yep, I got it. 1 hour, 47 minutes.
Yeah.
Thanks very much for that. I didn't know that that existed. So that's great background material to digest.
Yeah, that is a fantastic. I was looking for my lecture, but okay, go ahead. I try to find my lecture of the past year.
Perhaps I should know the question, the answer to this, but is there in fact a group within SRI who are doing specific studies of lunar colonies? Anyone?
I found it. I think so.
Actually, Adriano, may I say something?
Please.
When I mentioned before about the domes or other structures that would be covered by regolith, the illustrations from the ESA model are that the drones that would be doing this would in fact be, I think, as you were saying, 3D printing, in fact, a lattice work from lunar regolith to be a much more solid structure on top of the other structures.
Yes, it is the famous picture of the Norman Foster idea of Moon Village that came from the project made by Enrico Dini. Enrico Dini is an Italian entrepreneur. He is the inventor of the 3D printing for building. So he made a big 6 meter wide plotter.
Right.
Plotter that drops an chemical ink. He calls it ink, inchiostro.
Ink, yes.
That thing make the sand solid. So it with a picture, of course, something like a CAM, no? He built walls. So in 2010 he made a project for ESA, and he printed 3D printed a piece of wall, a lunar wall, made with a simulant of regolith. And upon that, upon that project, the concept of a lunar village grow up. And Norman Foster, the architect, they call it the Archistar, no, was in the project group, and he made those beautiful pictures of the the moon village with the robot making 3D printing of the thing.
Does everyone know that those illustrations by any? I'm just asking. Has everyone seen those illustrations?
Yes, it came from that project. By the way, that was only let me say a fantasy illustration, because many studies were made after that about what would be the best way to build, to 3D build on the moon. And definitely to have a big plotter would not be a good idea, because you have to bring too many things from Earth, very heavy things, and so it will not to talk about the chemical components and a lot of other things. Therefore, several trade-offs were made, and at the end, one of the most interesting things to do, apart the polymer, combining polymer and regolith that I talked before, was also the sinterization method, using a lens to concentrate the sun rays, so to melt the regolith. The regolith is similar to glass, therefore it can melt and make solid blocks. So this is maybe one of the best ways to build on the moon. But it could be that during the last years some other studies were made, and I'm not informed about that. So, but of course we can search. The only problem is time, but we can search by Google and find what is the state of the art of that kind of studies.
I think on the moon, yeah, if we build sometime greater structures, we have no steel reinforcement in this method. So of course we should, for greater structures, we should have another methods, and not just these bricks of regolith.
No, of course.
Regolith.
Yeah, we also have to go in the
underground,
the lava tubes,
yeah.
lava tubes.
Lava tubes,
Yeah.
of course.
Yeah.
It's the better solution, I think, in the long run.
Yeah. Good. I think we had a very good conversation, a very beautiful presentation, some interesting concepts raised up. So I think we have to take this material and keep on working on that, maybe for the next for our next meeting. That will be, let's see when it will be, if we have already scheduled. Let me check. Academy.
Adriano, can I just mention that I put a link in the chat for anyone who isn't really looking at that, about a NASA study that carried out in 1975. You can download the whole thing for free as a PDF.
Good.
Very worthwhile.
Thank you. Thank you very much.
You don't already have it.
So, okay, I'm afraid our next meeting will be the 13th of September. 13th of September, some of us will be in New York maybe, but okay, we can make it anyway. Okay.
Adriano, it's not good to have it 2 days before the UNO meeting.
Yes,
on the 15th we are busy with
before I knew the other date of the United Nations meeting. So of course we can.
Maybe we can update.
Or make it easier and Okay,
Yeah, we can maybe move the date. We will think about
Yeah.
in time. Okay, good. So if any the Martian way is a Casimov. That's interesting too. Yes. Yeah. By the way, if we think about Mars, then there are other things to be considered. On Mars, I think I don't know. I think there is very much iron on Mars, and I don't know what could be the process to extract iron from the rocks and from the sands or where it is. However,
It's iron oxide. You can extract like you do on Earth.
yeah, okay. However, okay, let's not open the discussion now. It will be for the next time, okay? Okay, thank you very much, everybody.
Great. Thanks very much indeed, Adriano, for organizing this. Well done. Thank you.
Thanks to all of us.
And thanks, Werner.
Adesso.
Thank you.
Bye.
thank you all of us.